Good morning, everyone. I wanted to help you with your corrections for the cumulative review 4. Now, one of the things that I suggested is to go ahead and do number 2 first, because we really could use a graph or a grid for number 1, and there is not one provided. So if we go ahead and do number 2, then we can come back and use the grid for number 1. So it says, what is the total length of segment EF and segment KL? So if you look at EF, so you're going to count how many units from E to F. So if I just trace from point E, it's going to be 1, 2, 3, 4, 5, 6 units. So from E to F is 6 units. Now for KL, so I'm going to start at K, and I'm going to trace down to L. So that's 1, 2, 3, 4, 5, 6, 7, 8. So KL is 8 units. So for the total, I'm going to take EF and KL, and I'm going to add them together. So 6 plus 8 is, of course, 14. And so number 2, you should have selected A. All right, so once you have that, let's go ahead and use this same graph for number 1. So I'm going to clear what I have here. And I'm going to go back to number 1. And I'm going to plot these points, and I'm going to connect them as I go. I think that was really the key. So first I begin with point A, which is the point -1, 3. So I locate the origin. I'm going to go to the left 1 and up 3. So my first point is here. Then, so I have this one. I'm just going to kind of mark these off as I go. The next point is 2, 3. So from the origin, I go to the right 2 and up 3. So here I am. And I'm going to connect those dots. All right, so I have that one. Then I'm going to go 2, -2. To the right 2 and down 2 from the origin is here. So again, I'm going to connect each dot to the one before. Then 4, 2, 4, -2. So I go to the right 4 and down 2. So here we go. All right. Then I have 4, 3. So to the right 4 and up 3. Here we go. Next is the point 7, 3. Now this graph doesn't go out that far, but I can sort of extend this a little bit. So this goes out to 4, so this would be 5, 6, 7. So 7, 3 is going to be somewhere about in here. So I'm going to go over there. And then 7, 5 is just going to be 2 up from that. And then -1, 5 from the origin, I'm going to go to the left 1 and up 5. So I'm going to connect that. And I can see if I connect that last point with the original, I can see that I have the letter T. So the points in number 1 create the letter T. Okay, moving on. Number 3, what is the area in square meters of the triangle shown? Well, I think we all know at this point that the formula for the area of a triangle is 1/2 times the base times the height. The problem is, if we look at it from this vantage point, the base would be this, and I don't know how long that is. If that's the base, the height is 16.5, but I don't know the base. The 5.8 really is not even a measurement of the triangle at all. If you will take your paper and turn it so that the base is this side, which is perfectly legal to do. If that's the base, if you turn it around, turn your paper around so that that's the base or bottom of the triangle, then the height would be this here. And that was really the key here, was to figure out which side to call the base and then from there determine the height. You have to remember that the base and the height will always be perpendicular. And I think some people remembered that, and some of you selected 5.8 as the base. But again, the dashed lines indicate that 5.8 is not actually a measurement of the triangle at all. So, we're going to call the base 24 and the height 7, and that will help us to calculate the area. So, of course, half of 24 is 12. And 12 times 7 is 84. So the area of this triangle is 84 square meters. All right, moving on to number 4. The area of trapezoid RSTU is 579.5 square inches. What is the length in inches of ST? Okay, so once again, we're going to need a formula. We'll have the area of a trapezoid, which is 1/2 times the height times the sum of the bases. So let's just take this formula and plug in everything that we know. I know the area is 579.5, so in place of A, I'm going to put that. I see that the height of this trapezoid is 19. One of the bases is 25, but I don't know the other base. In fact, that's what I'm trying to find. So side ST, I'm going to call base 2. And when I find that, I'll have my answer. Now the first thing I'm going to do is multiply 1/2 times 19, which is 9.5. The next thing I think I'll do is divide both sides by 9.5. Back to those solving equations skills. Now the reason I'm dividing both sides by 9.5 is because 9.5 is multiplied by the sum of the bases, and I want it to go away. Now, I used my calculator to divide 579.5 by 9.5, and I got 61. So 61 is 25 plus base 2. 61 is the sum of the bases. I can simply subtract 25 from each side, and 61 minus 25 is 36. Subtracting 25 from 25 makes that go away. I bring down the b sub 2, and so base 2 is 36. And remember, base 2 is what I'm calling ST, and that's what I was looking for. So the correct answer is ST is 36 inches long. Number 5 says, which is not a net of a prism? It's important that you know what the definition of a prism is. A prism is going to have two parallel bases that are the same shape, and then the lateral faces will all be rectangles. This first one, answer choice A, is a prism because it has two triangular bases. That would be this triangle and this triangle. Those would be two parallel bases. They are the same. And if you fold this up, you would have your three rectangles going around the sides. So this one is a triangular prism, and so we do not need to select that because we're going to select the ones that are not prisms. All right, so this is a triangular prism. Now part B, hopefully you recognize as a box, also known as a rectangular prism. In this one, the bases are rectangles, and since all the sides are rectangles, you can select which two pair of rectangles you're going to call the bases. Now, C is a cube, but a cube also fits the definition of a prism. It has two square bases, so we could call it a type of square prism where the height is equivalent to the sides of the squares. Now this next one, D, only has one base. The base is the square. And then around the square, you're going to have, it's going to be surrounded by triangles that all come to this point. Therefore, this is a square pyramid. A pyramid only has one base, not two bases like the prism. So for B, for example, I might call these two rectangles the bases. And for a cube, again, let's see, if I call this the base, then the other base I think would be this one. I think those would end up being parallel to each other. But when you have a pyramid, you only have one base. And we are supposed to be selecting the ones that are not prisms. A pyramid is not a prism, so I'm going to select D. Now for E, I have these two pentagons. Those, if we fold this up, these are going to be parallel faces. These will be our bases. And the rectangles will just wrap around the sides and become the lateral faces. So this fits the definition of a prism. It is a pentagonal prism. Pentagonal because the bases are pentagons. And the last one, we have one base that is this triangle, and then all of these other triangles fold up and come to a point. So this will end up being a triangular pyramid. Only one base. And this one is not a prism, so I'm going to select this. So for number 5, you should have selected D and F. All right, number 6. A closed rectangular container measures 28 centimeters long, 9 centimeters wide, and 13 centimeters high. What is the surface area in square centimeters? All right, so if I want to draw a little sketch of this, I have a rectangular container, also known as a rectangular prism. It is 28 centimeters long. It is 9 centimeters wide and 13 centimeters high. Now, the base, the bottom, is going to be the same as the top. This is the base. It is a 9 by 28 rectangle. In fact, I'll just draw the rectangle. So this is the base. It is a 9 by 28 rectangle. So this side is also 28 and this side is 9. This is important because I'm going to need two measurements from the base. I'm going to need the perimeter of the base, so I need to add up the sides. And when I do that, I get 74. I also need the area of the base. And of course, if the base is just a rectangle, I simply multiply the length and width together. So 28 times 9 is 252. Now I need those measurements because I'm trying to find the surface area of this figure, and the formula for the surface area of a prism is the perimeter of the base times the height plus 2 times the area of the base. So the perimeter is 74. The height, remember, is 13 plus 2 times the area of the base is 252. Now remember your order of operations. You have to do multiplication before addition. So I need to multiply 74 times 13 and 2 times 252, and then finally I'll add them together. 74 times 13 is 962, and 2 times 252 is 504. And this sum totals 1,466. It is the surface area of this rectangular prism, and that's exactly what I was trying to find. So that's answer choice A. All right, number 7, we have another rectangular prism built with small cubes. It says, what is the volume in cubic inch of each small cube? Well, first, let's find the volume of the entire figure. So volume is the area of the base of a prism times its height. Now the base of this prism is just a rectangle. So we'll just do length times width of the base times the height. So we have the length, we have a width, that's the base, and then we have our height of 1. So we can just multiply 2 times 3/4, and if you're using a calculator, you could call that 0.75, but I'm just going to leave it as a fraction because I think for me, it's easier. So 2 times 3/4, remember when you multiply fractions, you can think of this as 2 over 1 times 3 over 4, and of course 1 is just 1 over 1. So multiplying fractions, you simply multiply the numerators. 2 times 3 times 1 is 6. And the denominators, 1 times 4 times 1 is 4. And I'm going to go ahead and reduce this to 3 over 2. Now I have found the volume of this entire rectangular prism, but my task is to find the volume of each little cube, so just one cube. So my strategy is I'm going to count how many cubes there are, and then I will divide the total volume by the number of cubes, and that should tell me the volume of one cube. Well, let's see. There are 1, 2, 3, 4, 5, 6, 7, 8 cubes going across. They are 1, 2, 3 deep. 8 times 3 is 24. And there are 1, 2, 3, 4 layers. And 24 times 4 is 96. So there are 96 small cubes. All right, so once you figure out that there are 96 small cubes, you can take your total volume, which is 3/2, and divide it by 96. Now you can think of it as 96 over 1. Remember, when you divide fractions, you keep, change, flip. Now 3 goes into 3 one time, and 3 goes into 96 32 times. So I can make this a little easier on myself. In the numerator, 1 times 1 is 1, and in the denominator, 2 times 32 is 64. So the volume of 1 cube is 1/64. Number 8. The diagram shows the outline of a building. The side length of each grid square is 10 meters. A man is standing within the building 20 meters from segment AD and 30 meters from segment AB. What are the coordinates of the point representing the man's location? All right, so these are walls of a building, and the man is inside this building. So he's at some point inside here. If he's standing inside the building and he is 20 meters from segment AD, so here AD is here at 40, so 20 meters away would be here. So he's standing somewhere along that segment. He's also 30 meters from AB. So AB is this left wall, so come in 10, 20, 30. So 30 meters this way. And he's going to be somewhere along that segment. And those two segments intersect right here at -10, 20. And that's why you should select A. If he's standing at -10, 20, he is 20 meters away from segment AD and 30 meters away from segment AB. Moving on. Number 9, we have a regular hexagon. The shaded region is 13.2 square centimeters. What is the area in square centimeters of the regular hexagon? If I draw another dashed line right here, hopefully you see that there are 4 congruent segments here. We are told that this area is 13.2. That must mean that all 4 of these have an area of 13.2. So if I want the area of the entire hexagon, I can just take the number 13.2 and multiply it by 4. And if you do that, you're going to get 52.8. And that is the area of the entire hexagon. Number 10. Jason has a bottle that is a rectangular prism. The bottle measures 9 centimeters long, 7 centimeters wide, and 21 centimeters high. Jason filled it completely with water and then drank 2/3 of it. How many cubic centimeters of water were left in the bottle? This is the key. How many centimeters of water were left? First, let's find out how much water was in the bottle. If it was completely full, we know to find the volume of a rectangular prism, we're going to do the area of the base times the height. And when the base is a rectangle, that simply means the base is length times width times height. So the base is 9 by 7, and the height is 21. So we're really just multiplying 9 times 7 times 21, and we're going to get 1,321. So that's how much water is in the bottle. 1,321 cubic centimeters is the total amount of water in the bottle. Now Jason is going to drink 2/5 of it. I am not that interested in how much water Jason drank. I want to know how much is left in the bottle. So if he drank 2/3 of the bottle, then the remaining amount is, if he drank 2/5 of the bottle, then the remaining amount is 3/5. So I want to take 3/5 of 1321, which means multiply. So again, you can put this over 1 if you want. You're going to multiply 3 times. So basically you're going to do 3 times 1,321, and you're going to divide by 5. And doing that will result in 793.8. 793.8 cubic centimeters is the amount left in the bottle. Many of you multiplied by 2/5, so you found how much water Jason drank, not how much was left in the bottle. Number 11. Points M, N, and P are 3 points on a coordinate plane. The coordinates of point M are -3, 2. The coordinates of point N are 4, 2. And point P is in the 4th quadrant. Plot these points on the given coordinate plane and then join them to form a right isosceles triangle MNP. All right, M is at -3, 2, which is right here. So I'm going to plot that point and label that point M. N is at +4, 2, which is here. So one side of my triangle is here. The only thing I know about P is it's in quadrant 4. So I know that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So I know it's somewhere in the bottom right portion of the graph. Now I have some other clues. I know that when I plot point P, it is going to form a right isosceles triangle. Isosceles triangles have 2 sides that are the same length. Okay, so this side, if I count, it's going to be 1, 2, 3, 4, 5, 6, 7. Now, in order to be in quadrant 4, I'm just going to have to come straight down from N 7 units. 1, 2, 3, 4, 5, 6, 7. So now this side, NP, is also 7 units. And then I can just connect M and P to finish off my triangle. And because MN is a horizontal line and NP is a vertical line, then these are perpendicular, creating a right angle. So I have point P in quadrant 4. I have 2 sides of my triangle the same, so it's an isosceles triangle. There's a right angle, so it is a right triangle. Now I just need the coordinates of point P. To get to point P from the origin, you're going to go to the right 4 and you're going to go down 5. So point P has coordinates 4, -5. Now you will need to explain in words, because I believe that's part of it. It says, what are the coordinates of point P, and explain your answer. So I will read you what I wrote. An isosceles right triangle has 2 sides that are congruent, or the same length. Since MN equals 7, then P is either 7 units from M or N. Since P is in quadrant 4, then it must be 7 units down from N. You can explain it however you like, but in your own words, please describe how you get point P. All right, number 12. Figure HKLM is a trapezoid. The length of JK is 1/2 the length of HI. What is the total area of the shaded regions? All right, I've seen a couple of different approaches to this problem. I decided to find the area of each triangle and add them together. But the first thing I need to do is figure out the length of the bases of the triangles. I see that both triangles have a height of 40 feet. Okay, this is going to be 40. This is going to be 40. And we have these perpendicular lines here. So I just need to find the bases. Now I know that because we have this rectangle, this white rectangle in the middle, I know that from I to J is 33. And since JK is half the length of HI, then whatever JK is, I'm going to call it X. I know that HI is twice as much. And I also know, furthermore, that if you add these three sections, the entire base of the trapezoid is 75 feet. So I know that if you add 2x plus 33 plus x, you're going to get 75. I'm going to use that knowledge to help me solve for x so that I'll know the bases of my triangles. So we've solved equations. I'm going to combine my x's. 2x plus 1x is 3x. So my simplified equation is 3x plus 33 equals 75. I'm going to subtract 33 from each side because that's how I get rid of a plus 33 with opposite operations. Adding 33 and subtracting 33 are opposite operations. They add to 0. And so I just bring down the 3x. Now, 75 minus 33 is 42. Now, to solve for x, since 3 is multiplied times x, I'm going to divide both sides by 3. Dividing by 3 cancels out the 3 that is multiplied by x, and 42 divided by 3 is 14. So that tells me that the base of this small triangle is 14, and the base of this bigger triangle is 2 times 14, or 28. All right, so I'm going to find the area of this triangle using the formula for the area of a triangle, 1/2 times base times height. So 1/2 times 28 times 40. And that turns out to be 560. Then I'm going to find the area of this smaller triangle using the same formula, but this time the base is 14 and the height is 40. This turns out to be 280. It's no surprise to me that the smaller triangle is half the area of the bigger triangle, since the base is half the base of the bigger triangle. So now for the total area, I'm simply going to, the total area of the shaded regions, the total area of the two triangles is just the sum of these. So I'm going to add 520 and 280, which gives me 840. And since it's area, I'm going to use square units, and the units are feet. So 840 square feet. Number 13. Points W, X, and Y are shown on the coordinate plane. Ella wants to draw a parallelogram WXYZ. At which location of the coordinate plane should she plot point Z? And what is the area of this parallelogram? All right, let's first do the task of finding point Z. So parallelogram WXYZ, we will trace the points in that order from W to X, from X to Y, and from Y to Z. One thing I know about a parallelogram is opposite sides are parallel and congruent. This side from W to X is 1, 2, 3, 4, 5 units long, and it is horizontal. So for point Z, it should be 5 units from point Y, and it should be parallel, so also horizontal. So from Y, I'm going to go over 1, 2, 3, 4, 5, right here. Okay, and so from Y to Z, and then from Z back to W. There's my parallelogram. So Z is located at the point 1, 5. Now I want to find the area of this parallelogram. And the formula for the area of a parallelogram is base times height. The base, I'll just call this the base, which is 5 units. The height is how tall it is. So let's see how tall it is. So it goes all the way from the bottom to the top. Let's see, that is 1, 2, 3, 4, 5, 6, 7. So the height is 7. So the base is 5, the height is 7, and 5 times 7 is 35. And I don't know what these units are, but area is always square units, so I'll just say U squared for units squared. For number 14, it says name the solid each net forms. We looked at something similar to these earlier. This first one, we have this triangle base. All the other triangles will fold up, and these points will all meet to be the tip of the pyramid. So this is a triangular pyramid. Remember that a pyramid, like a prism, is always named for its base. And since its base is a triangle, it's a triangular pyramid. This next one, I see 6 squares, all the same size. This has to be a cube. Now, if you said it was a square prism, you're partially right. Yes, it is a square prism, but a better name is a cube. Because a square prism can be something like this, where you have a square base, but the height could be really big, like this. And so cube is better because then it tells you not only are the length and width the same, but the height is also the same. Number 15, Tyler wants to wrap a present that is a square pyramid. The square pyramid has 4 faces that are congruent isosceles triangles. How much of the wrapping paper in square centimeters will he have left if he has 820 square centimeters of wrapping paper at first? So we're going to find the surface area of this figure, and then we're going to subtract that from 820 to figure out how much wrapping paper he has left. Now, for this triangular pyramid, the surface area, we're going to find the area of the base, which is actually already given to us. The area of the base is 324 centimeters squared. Plus, we also have these 4 triangles that go around the sides. So I'm going to find the area of the triangle, and multiply it by 4. So I'm just going to find the area of one of these triangles. So I already know that the area of the base, that's capital B, is 324 centimeters squared. So I need to find the area of the triangle. There are 4 of these. So this is 12 centimeters. I need to know the base. Well, the base is a square where the area is 324. So to find each side, I know that to find the area of the square, you take the side length squared. So since the area is 324, to find the side length, you're going to take the square root of 324. And you're going to get 18. So the sides of the base are all 18. And the side of the base is also the base of the triangle. All right, so now I'm ready to find the area of the triangle. It is 1/2 times the base times the height, or 1/2 times 18 times 12. And that is 108. So I'm going to go back to my surface area formula. The area of the base was given, that was 324, plus I have 4 triangles that all have an area of 108. Once again, don't forget to do multiplication before addition. So 4 times 108 is 432. And when you add 324 plus 432, you get 756. $756 is the total surface area of this figure, and that's the surface you will need to cover with wrapping paper. Tyler has 820 square centimeters of wrapping paper. He's going to need 756 square centimeters to wrap this gift, which is going to leave him with 64 square centimeters remaining. So we write 64, bubble the 6 and the 4. All right, number 16, we have a solid made up of identical cubes. The volume of the solid is 1,536 cubic centimeters. What is the edge length in centimeters of each cube? First thing you should do is count the cubes. I notice on the bottom there are 1, 2, 3, 4, 5, 6, 7, 8, and then 9, 10, 11, 12. And you can double that because this is 2 cubes deep. So I know that there are 24 total cubes. The total volume is 1,536 cubic centimeters. So I can just divide that by 24 to figure out the volume of 1 cube. And that gives you 64. So that is the volume of one of the cubes. But that is not the question. The question says, what is the edge length in centimeters of each cube? So let's just focus now on 1 cube. Okay, the volume of the cube is 64. So we have these edges, I'll just call them E here. And I know that since a cube is a type of rectangular prism, I'll just do length times width times height to get the volume. So 64 is the edge cubed. So I need to know what number multiplied 3 times gives me 64. In other words, what is the cube root of 64? turns out to be 4, because 4 times 4 times 4 is 64. So each edge is 4 units. So the answer is 4. Boom. All right, for number 17, I want to be very systematic here. So I'm going to start at point P, and I'm going to go around the figure counterclockwise. So I'm going to find the length of each segment. So from P to Q, now each one of these represents 20 meters. So 20, 40, 60. PQ is 60 meters. Then I'm going to go from Q to R. 20, 40, 60. So Q to R is also 60. Then I'm going to go from R to S. So that's going to be 20, 40, 60, 80, 100, 120. Then I'm going to go from S to T. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Then from T to U. 20, 40, 60, 80, 100, 120. Then U to V. 20, 40, 60. Then from V to W. 20, 40, 60. And finally from W to P. 20, 40, 60, 80. And then I'm going to add these up to find the total perimeter. So if I add these up, the total perimeter is 760. Now some of you had a little different strategy here. Instead of counting by 20s, you simply counted up the perimeter as if each square represented 1 unit and then multiplied your final answer by 20. And that should also work. Number 18, a truck uses 1 gallon of diesel for every 6 miles traveled. The graph shows the amount of diesel left in the tank, X gallons, after traveling Y miles. Part A is on the next page. It says how many gallons of diesel are left after the truck has traveled 75 miles. It's just a matter of reading the graph. So miles is on your y-axis, so I find 75 miles, and I go to the graph. I locate this point, and I figure out how much diesel. Go down here. So that is halfway between 20 and 25, and halfway between 20 and 25 is 22.5. So part A is 22.5. So 22.5. So I'd have 2.5. After the truck has traveled 120 miles, how much farther in miles can the truck travel before it runs out of diesel? Let's go back to the graph. All right, so 120 miles is way up here at the top. Let me scoot this down just a bit. So I see 120 miles, and I find this point. Then I follow this down to the x-axis to find that that corresponds to 15 gallons of diesel remaining. All right. So after traveling 120 miles, we have 15 gallons of diesel remaining. That was not the question. The question says, how much further in miles can the truck travel? So if we have 15 gallons of gasoline left, how far can we travel? Well, if you remember, we were told at the beginning, you can flip back there and see, that this vehicle is going to get 6 miles per gallon. And we have 15 gallons. So we can simply multiply these numbers together and find that 15 gallons will take us 90 miles down the road. And then we'll run out of gas. So 90 was the correct answer here. Number 19. The ratio of the length to the width to the height of an open rectangular box is 12 to 3 to 5. The length of the box is 27 inches more than the width. What is the surface area of the open box? Write your answer and your work, or explain in the space below. All right, so we're given a ratio for the length to the width to the height. It is 12 to 3 to 5. Now we're told that the length is 27 inches more than the width. So that should mean that if you take the length and subtract the width, it should be 27. But in this case, the length is 12 and the width is 3. And 12 minus 3 is not 27, it is 9. But if I multiply 9 times 3, that does give me 27. So why don't we try to multiply these times 3? So 12 times 3 would be 36. 3 times 3 is 9. And 5 times 3 is 15. Now, the length minus the width is 36 minus 9, or 27. So the length is 27 more than the width. So these are our length, width, and height. So if I draw the box, okay, it's 36 by 9 by 15. Just a little sketch here. 36 by 9 by 15 high. Now, it is an open box. That's important because that means it doesn't have a lid. So when I find the surface area, I'm going to do the perimeter times the height plus only one base, not the usual 2 bases, because there's a bottom but no top. All right, so I've got my strategy lined up here. I'm going to focus for a moment on the base, the rectangular base, the bottom of this box is 36 by 9. Of course, the height of the box is 15. So the perimeter of the box would be 36 plus 9 plus 36 plus 9, adding up all the sides, and that totals 90. And then capital B represents the area of the base. The area of the rectangle is length times width. In this case, 36 times 9, which is 324. So, my surface area is the perimeter, which is 90, times the height, which is 15, plus only one base since it's an open box. Remember to do multiplying before adding, so 90 times 15 is 1,350. And when you add that to 324, you get 1,674 square inches. All right, I'm going to save the bonus till last. I'm going to move on to number 21. We'll come back to that one. Number 21, it says a student filled a rectangular box with 1-inch cubes to find the volume in cubic inches of the box. Below shows the student's work. Student's work. I packed my box full of cubes. Each cube has a volume of 1 cubic inch. I counted 32 cubes in the top layer. Since there are 11 layers of cubes below the top layer, I solved 32 times 11 equals 352. So there are 352 cubes. I concluded that the volume of my box is 352. Well, if we look at the top layer, there are 1, 2, 3, 4, 5, 6, 7, 8 cubes across, and it's 1, 2, 3, 4 cubes deep. So we would call this the base, basically the area of the base is length times width, or 8 times 4, or 32. So that top layer, you could also call it the bottom layer, is correct. That's 32. Now, the thing is, you have to add all of these layers together. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total layers. Okay, so 12 layers total. You can't just skip the top layer. You've got to multiply all layers. So to find the volume, you do the area of the base times the height. So that would be the area of the base, which is 32, and the height is 12, not 11. So 32 times 12 is 384. And so the proper volume is 384 cubic inches. Now, part of this solution says, explain why the student's reasoning is incorrect. So I wrote, the student miscounted the height. There are 12 layers total, not 11. Or probably what happened is they left off the first layer. But you must count the first layer as well. Part B says a second box also has a base of 32 square inches, but has a volume of 480 cubic inches. What is the height in inches of the second box? So again, we'll use our same formula. The volume of a box is the area of the base times the height. So we know the volume is 480. The area of the base is 32 again, but we have a different height. So to solve for the height, I can simply divide both sides of my equation by 32, because dividing by 32 gets rid of a multiply by 32 on the right side, and 480 divided by 32 is 15. So the height of my new box, rectangular prism, is 15. Number 22. This question has 4 parts. So tree A is 200 centimeters tall. It grows 40 centimeters taller in 2 months. Tree B is 240 centimeters tall, and it grows 60 centimeters taller in 5 months. The diagram below shows the relationship between the heights of the 2 trees. Which tree grows faster every month? Write your answer and explanation in the space below. Well, there are a lot of ways to do this. If you go back to the information for tree A, it grows 40 centimeters in 2 months. So 40 centimeters in 2 months means it grows 20 centimeters in 1 month. Now for tree B, we are told at the beginning that it grows 60 centimeters in 5 months. So 60 centimeters in 5 months. And 60 divided by 5 is 12. So it's growing 12 centimeters per month. So tree A started out smaller, but it's growing faster. And that's the question, is which tree grows faster? So because of this, I can see that tree A grows faster. The other thing you can see is when you look at the graph for tree A is steeper than the graph for tree B. So that's another way to show that it's growing faster. Now the next question, part B, says what is the height in centimeters of tree A after 7 months? So we just need to find 7 months along our timeline and go up to tree A. So if we go up to tree A, it's right here. That corresponds to 340 centimeters. Okay, so part B is 340 centimeters. And we just get that straight from reading the graph. All right, almost done here. Part C says if tree B is at least 350 centimeters tall, how many months have passed? Okay, at least 350. So let's go back to the graph. So let me erase what I have here. So 350 centimeters, so it'd be 300 this or above. So tree B be here or more. So tree B keeps growing. Well, if you look down here, follow this down, roughly, it's a little bit more than 9. So time is going to keep going as the tree is going to keep growing. And so the time in months must be greater than 9 months. Okay, because that point is just a little bit past 9 months. And so to answer part C, I would simply use, I would say T is greater than 9. Here's what I wrote in my explanation. I wrote, locate the point on the line representing the growth of tree B where the tree reaches 350 centimeters. This corresponds to just over 9 months. So be sure to include your explanation. Last part. Tree A will be as tall as tree B after K months, where K is a whole number. What is the value of K? Now remember, when tree A starts, it is shorter than tree B. When it begins at 0 months, tree A is 200 centimeters tall, tree B is 240 centimeters tall. They both grow. Tree B grows slower than tree A, but at some point they are the same. And thereafter, tree A is taller at any given month. But tree A catches up to tree B after 5 months. And so that's going to represent K in this problem. So we will say K is 5 months, and then explain how you get this. So here's what I said. I said, tree A begins at a height of 200 centimeters, and tree B begins at a height of 240 centimeters. Tree A catches up to tree B at 5 months when both trees are 300 centimeters tall. After 5 months, tree A is taller than tree B. All right, that concludes this cumulative review. I am going to go back and do number 20 if you care. This was our bonus question, and it was tough. The figure below shows two overlapping squares. The ratio of the area of the small square to the area of the big square is 1 to 4. The shaded area is 1/16 of the area of the big square. The total area of the unshaded regions is 54 square meters. What is the area of the small square? Okay, so the first thing I notice is that I want to use this ratio to establish that the area of the big square is 4 times as much as the area of the little square. Now the area of the shaded region, I'm just going to call it SR, okay, is going to be 1/16 the area of the big square. So if you take the area of the big square and divide it by 16, you'll have the area of the shaded region. But remember, the area of the big square is just 4 times the area of the little square. So if I make that substitution, 4 over 16 reduces to 1/4. So the area of the shaded region is the area of the little square divided by 4. Okay, here's the other thing I note. So the unshaded region. So the unshaded region. If you were to take the area of the big square and add the area of the little square, you would be adding this shaded region twice. So if I take away 2 of the areas of the shaded regions, then that will leave just the area that is unshaded. And we are told that the unshaded region is 54 square meters. Now, my final answer is I want the area of the small square. So I'm going to write everything in terms of the small square. So the first thing I wrote is the area of the big square is 4 times the area of the small square. So I'm going to make that substitution here where it says area of the big square. I'm going to put 4 times area of the small square plus area of the small square minus 2 times the area of the shaded region, and the area of the shaded region is equivalent to the area of the small square divided by 4. All right, if I can solve this equation for the area of the small square, I'll be good to go. So I have 4 times the area of a small square and 1 times the area of a small square, and I'm adding those together. That's going to be 5 times the area of the small square minus. And I can think of this as 2 over 1, and I can simplify this to 1/2 the area of the small square. So I have 5 times the area of the small square minus 1/2 the area of the small square. So I can just combine those by subtracting 1/2 from 5. So 5 minus 1/2 is 4.5. I'm just going to write it as 4.5 for the sake of simplicity here and for the use of my calculator. So 4.5 times the area of the small square is 54. I'm going to divide both sides by 4.5. And the area of the small square is 12 square units. Now this is by far not the only way to solve this problem. It might not even be the best way to solve this problem, but it is certainly a way to solve this problem. And it was a hot mess, which is why it was a bonus question. And by the way, I got it wrong the first time I solved it, so don't feel bad. All right, I hope this helps. Thank you for your patience.